So ChatGPT did a pretty good job of making a bunch of questions. And I've got them on here, but I started looking at it this morning. And I knew I was going to have to audit it, and there are some mistakes in there. But we'll review significant figures, multiplication, division, maybe scientific notation. And we'll see how far we get. We go till 9:50. See how far we get. We'll review what I started already. I use these questions and we'll audit them as we go. And I'll probably have to change the quizzes I've already made. But this is the actual database. So we're checking to see if these are right. So this is the way the question will look when you read it. This is indicating the correct answer, number 4. And let me remind you, these are for practice, not for a grade. And when you're done with the quiz, you're able to click in there and see what you got right and what you got wrong. So it's just for you to practice, to drill and see if you got it understood. So I had ChatGPT make 50 questions of these different types of questions I wanted to make. So I've got 50 in the database, and the way the quiz works is it just grabs a random 5, gives you 5 to practice, and then you can check your score. And then you can do the quiz again, and it'll grab another random 5. So I could make a bigger database, but I want to make sure it's working correctly. So the question to you is this correct? Did ChatGPT do this one correct? 23.40.
Yes.
Yes.
23.40. Did that for the camera. So it did this one right. I came in here this morning, y'all saw me walk in, and I opened up the 5-question random thing for this, and there were 2 of them that were incorrectly done. So I started to go down this list. Help me remember what number we're on. Here's number 2. Is this one correct? Yep. There's no zeros, so you just count the digits there for that one. Go back. Now we're on number 3. Is that correct? Leading zeros don't count.
Yes.
This one's correct. Was that number 3 I was on?
Yes.
4.
Yeah, that's the correct.
Yeah, that's right.
He gave you this hint too. This one. 5.
Yeah, that's
Correct. Number 6.
Yeah, that's correct.
Yep. Trailing 0 counts. Leading zeros do not. 7.
That's correct.
Is the quiz or is the thing titled Significant Basics?
Yeah. That's the database I'm going through. If you click on that now, it'll give you 5 random questions. But I know some of them are wrong, so I need to go through all 50. But I figure we'll go through enough of these that I can at least post these, the ones we go over. I'll have to go through all 50 to find out. Find out if they're correct. I already did that one. Up to 8.
That's correct.
Correct.
Yeah, that's correct.
I know some of these are wrong. Is that 10? What number?
Yeah, I think that was 10. I think we're on 11 now.
There's a typo.
Somebody said some of the questions were wrong.
That was 11.
Yeah.
Dr. Weber,
Yes.
a lot of the questions have like double answers.
Yeah, I noticed that. And this we should be 1, 2, 3, 4, it should be that. Yeah, I see. I didn't notice that when I was doing this last night. How many should this one be? 3. It is 3. Crap, what number was that?
I think that was 12. I think, yeah, that was 12.
Let's get at least 20. Is this one correct?
Yeah.
Correct. No double answers. Should be 4, that's right. That's right. Let me just get to 20 and then I'll think of myself. Okay, whatever. Just do that one. 16. Yes, I did that. When you see these in scientific notation, all the digits you see there should be significant. There should be.
If there's a significant 0, would you include it in scientific notation?
Sorry?
Like if there's a 0 that's significant, would you include it in scientific
Yeah.
notation?
It's, those trailing zeros will be there.
Okay.
And if you've done scientific notation properly, you won't have leading zeros.
Okay.
That was correct.
Last night I asked them to say one AI stuff. I've seen you, I'm pretty sure.
This, you guys looking at that? Sig figs basically. I want to make a different one. Hide this one. Yeah, those 20 that we just did. I'm just going to put those in there so you have something. I will work this afternoon over the weekend to refine these some, so that this isn't so clunky. I hated leaving all this so little for practice. So I got on my little database here, and somebody got ChatGPT and how easy it is to do this, so. Sick Figs Basics 2 is what you should. Okay. And now, let's try this and see how it does. So that's going to grab a random 5 questions. So the way ChatGPT did this is you kind of don't even have to make the calculation. So I might refine that a little bit. If you just look at that multiplication problem, how many significant figures should there be? For number 1, 3.50 times 2.222. Oh, it's the rounding. Yeah, you do have to calculate these. So you know it's either the second answer or the fourth answer. Do you see that?
Yes.
Because when it's a multiplication division, you've got 3 significant figures there, 4 there. That means your answer has to be in 3, which means it's got to be that or that. The rounding, you can't tell until we do the calculation. So I'm going to do 3.50 times 2.222. My calculator says 7.777. That very last 7 rounds up to 7, so the answer is 7.78. Hopefully the answer key is correct. All right, the next one, the division. There's only one answer. Yeah. There's only one answer that has 2 significant figures in it, so I'll just click that. This is 3 significant figures times 2. So it's either the 67 answer or the 70 answer.
It's 67 because it's just 67 times 1.
Oh, yeah. There won't be any rounding, will there? It's gotta be this. So this one they round, yeah, oh yeah, that's got 1 significant figure. Yeah, I said that wrong. That doesn't have a decimal there, so that's only 1 significant. How many significant figures is this? 45.6?
Yes.
How many is that? That's 3. How many down here?
2.
Just those 2.
So then would your answer be 1 in scientific notation? Or no?
Yeah, I haven't said this yet, but unless a question asks you to put your answer in standard scientific notation, you don't have to. Some instructors will say at the beginning of the semester, always put your answers in scientific notation, and then I guess you have to always do it. But the correct answer is the correct answer, whether it's in that conventional form or not. This is 3 significant figures and 2 significant figures. We need 2. The way this is written, the first one and the third one are both correct. The 5700 put in standard scientific notation is this. So I'll have to go tinker with ChatGPT a little bit over the weekend to straighten it out. I don't know which one is going to count correct. I bet it does that. All right, this is how many significant figures?
3.
That one's 3. And there's 2. So our answer needs to be in 2. And there's only one of these. Yep, there's only one of these that has 2 significant figures. Submit quiz. And you should get this. Check your answers. That's wrong. I need to put the number of the answer down here. So, all right. So let's keep reviewing. Let's keep reviewing these, except we'll go to the database. Check what we see there. Multiplication division rule. Number one. You can call them A, B, C, and D. Which one do you think this is? There's two answers with three significant figures. These two. I bet it's the last one. Calculate this. 23.050 times 34, 2. So I get 788.31. You look at the 3 to see if it rounds the 8, and it doesn't, so you end up with just this. So it did this one wrong. Fix it. Right? 5 significant figures, 3 significant figures. Man, I'm disappointed in ChatGPT. I was so happy last night when I made all these. I knew I was going to have to edit them. 3 significant figures, 2 significant figures.
So it has to be 2.
So it has to be 2. This one's correct. 3. 3 and 2. So the only one that's 2. Right? That was number 3. 4. 3 and 3. It's got duplicate answers. Is that number 4?
That was number 3, I think. Oh, wait, no, you might, I don't know. Yeah, you were right.
I guess I can trust ChatGPT to do the calculation, right? What do you think about this one?
I mean, if it did the math right, then it's right.
120 divided by 26.3, so yeah, it did it right. There was no round in there. What number are we on? 6.
Yeah, 6 or 7. Yeah, no, it's right, it was 7.
This one's not right. You see what's wrong with this one?
It needs to be 3 sig. Oh wait, no, it needs to be 2 sig figs, right? Yeah. So it's 5.5.
It should be a 5.5.
I'm such a word warrior. So it's like, hey, like, I'm so sorry for this. Like, I was in my work here, and then it
that one right?
It's 2 sig figs.
Is that 8?
Yeah, that's right. They did the math.
Do that calculation.
Okay.
345 divided by 1.22.
No, I'm gonna come back Sunday.
Hey, you guys do this calculation. 345 divided by 1.23.
It should be 280.
With a decimal, right?
Yes, with the decimal.
You see what's wrong with this one? Your calculator will give you 280.48780, whatever. That 0.4 does not round the 0 up to a 1.
Was it around the 8 to a 5 and then 5 to a 1? Is that what can happen?
Round the 8 to a 5 and a 5 to
Yeah, because it's 0.48, so I think it just double rounded.
It's so, and it needs to be 3 significant figures. So it's
Oh.
only going to be the 280, possibly 0 or possibly 1, but that 4 doesn't round to 1, so it's a
Yeah.
big problem. So I gotta fix this one. What number was that?
I think that was 9, yeah. That was 10. Wait, you need to put a decimal.
Oh, right. This one is, yeah, it's this one. It's got a duplicate answer though.
It repeats.
Is this one correct?
That should be right. 2 sig figs.
Raise your hand if you think this is correct. Raise your hand if you think it's incorrect. Only 3 people raised their hand. Either you think it's correct or you don't. You think it's correct? Who thinks it's incorrect? It's not incorrect. Did I pull someone? Oh, what's that? 12? All right. How many significant figures should this answer be?
2.
There's So, and there's only one of them. What? So is it correct?
It's correct.
Assuming the math is correct. Okay, how many significant figures is here?
That's one significant.
You guys see that? That's one significant figure? How about the next one?
That's two.
This one? This one? How many should be in the answer?
Which question?
That's incorrect, because there should only be two sig figures.
You guys see what's wrong here?
For which question? Oh, the one.
This is one question. This is just showing the answer,
It should be 1.7.
assuming the math. is right.
Yeah.
What number was that?
I don't know.
It's just up there. So I'll put those 15. All right, we'll review addition, subtraction next.
Yeah, so you want to delete the first 15 or you want to select the first 15?
I deselected the first 15, so
Oh, gotcha.
unlimited attempts, so you can go through this as many times as you want. Ideally, I have a big enough database that you get different questions every time, different set of 5. But for now, I'm just going to put all the questions we audited into one. So I'm going to hide these until I fix them. So in order to see if you've got this understood, it's significant figures basics 2, significant figures multiplication division rule 2. All right, let's audit some of the addition subtraction
The
ones.
sig figs multiplication division rule 2 is hidden.
Thank you. Now you can do that. All right. Let's edit some of these and then I'll go into, I don't want us to spend all the class time editing my mistakes. Monterey. Addition, subtraction. Okay, and just as a reminder, we're looking at what's after the decimal for the addition, subtraction rule. We've got 1 digit after the decimal here, 2 here. That means I need an answer that has 2 after the decimal. Both of these have 2 after the decimal, so I'm going to have to do the math. What? It's the first one, right?
Yeah, I think so.
It should be this one. It's that one because that's the one that has 2 after the decimal.
His 123.4 only has one
Oh,
past the
yes.
decimal.
I got 129, yeah, that's it, 129.1. Is that what it had?
Yes.
My calculator says 129.07.
That's what mine says.
So the 7 rounds to 0 up.
Yeah, I get it.
So this one was correct.
Yes.
Sorry, ChatGPT. So 2 after the decimal, 1 after the decimal. We need one that has 1 after the decimal, and there's only one of them. So we'll assume it calculated it correctly. Number 2, number 3. 3 after the decimal, 2 after the decimal. This one has 2 after the decimal. That's right. 4. 2 after the decimal. Is this one right?
Yes. Yeah.
And what number was that? 3.
Yeah.
So we're on number 4.
Oh, no, that was number 4.
No, it was 4. 5. So how many do we need after the decimal?
Yeah.
How many do we need after the decimal?
4.
This one we have to do the math because there's 2 of them. We have 4 after the decimal. So we're basically checking to see if it's rounded correctly. 4, 5, 6 plus 4. So my answer is 0.00796.
So it's,
And we need 4 after the decimal. So we're going the 0079, we want to keep it. But we look at the 6, it tells us to round up. So this one's correct. 4 after the decimal. Notice this one has 0 after the decimal, and that's how you think of it. 0 after the decimal, this one has 2, so our answer has to have nothing after the decimal. So we're looking at these 2, and we're just checking to see if they're rounded correctly. Five, 6, 7. So this one does round up. 1260. 260. Right? That one should round up, right?
Yeah, it should be seen.
What number is this? 6? Yes, it is.
Yeah.
Now on 7. This has 3 after the decimal. This has 1 after the decimal. This is the only choice with 1 after the decimal. 7, 8, 1 after the decimal. That one's right. 9. So again, this one has 3 after the decimal. This one has 3 after the decimal. So 059 should be the answer.
Yeah.
3 after the decimal, the 5 rounds to 9, so okay. 059. All the numbers are 8. No. 7. More preview. What number was that? one that has one alpha decimal. So it has to be this one. 10. I'll just say those 10. I'll give these to you just so you can make sure you understand this as a drill to go through. But I want to fix them up so that it's actually real practice. So I'll fix all the, I mean, I want to have a big enough database that you can grab 5 questions, see how you do, and if you want 5 more, you can grab 5 more. The way I'm doing this now, just temporarily until I fix this, is all the ones we just edited, I'll just put all those in the quiz, but they're going to be the same ones we just saw, so that's not ideal. I guess we'll look at the scientific notation one, and then I'll cover density a little bit. Where- Is that correct?
Yes.
Everybody? Question?
Is the correct one to the -3?
Yes. And it looks like it did that one correctly. Maybe these are all correct. Let's go through 10 of them, and if they're good, I'll just leave it. Is that one correct?
You go over how to do some implementation.
Yeah. I'll review it. Let me go through 10 of these and just see.
Yeah, that one's correct.
Scientific notation for the number 7.
This,
It's just missing some zeros, I think. grab those 10. And then I'll review the scientific notation. I gotta get the. Has that screen been doing that the whole time? We still have technical difficulties. Let me know when that happens, because all I gotta do is jiggle that thing. Okay. Scientific notation. The first thing you want to do for scientific notation is figure out where is the first significant digit in your number, and your decimal needs to go right there to the right of it. Does that make sense? You asked. The decimal's here, but I need to get it here, just to the right of the very first significant digit. That means moving it that way to the right twice. That would be the same thing as multiplying it by 10 to the 2. That would achieve that. You see what I mean?
For the 2, is it when you go like a certain like left or right when it's
It needs to be negative.
Okay.
So I'm just building this piecewise. Do you see that adding this onto there moves the decimal? But what's wrong with that, if I've actually changed the value. I don't want to change the value of it. So what I do is that. I make it negative. Now it's the same value. That equals. And of course, when you put things in scientific notation, you can take off the leading zeros. You can tell though here that these are leading zeros and they don't count. So that's not really proper the way that is. It needs to be just 5. Yeah, 2 significant figures are preserved. Did that help?
Anytime you're the decimal that way, it's negative, then you want to move forward as positive.
Yeah, it's whichever way you're moving the decimal to get it to that spot, you need to do the opposite once you have the number written that way. That was like multiplying by 10 to the 2, but that changes the value of it. If you're going to put the decimal there, you need to put the negative there back to here. The double check is to look at your final answer and then calculate this, which causes this to move back twice, just to double check that you got your original value. Going the other way, if you have a big number with a bunch of zeros, and I said put that in scientific notation. The decimal is here, 1, 2, 3, 4, 5, 6. Times 10 to the negative 6 will get the decimal where you want it to be. But I changed the value. So what you really want to do is do 10 times the opposite sign. 10 to the 6 will turn this into 1, 2, 3, 4, 5, 6. Did that make sense? You still seem unsure. What else
I
there?
think it's just the same way of writing it, like both of those just means, like both of those equations ultimately are talking about the same number.
I don't understand your question. What if I did this? The decimal would be here, and I gotta go 1, 2, 3, 4, 5, 6 to get the decimal removed. But once I have the decimal here, how do I make this? So doing it a different way. Just move the decimal and put it where it's supposed to be and write it down below there. And then ask yourself, what do I need to put here to turn this number into that? Question mark. So that's your original number. Then put an equal sign and put the decimal where you know it's supposed to be. Then write times 10, question mark, and then figure out what is it I need to do to this to turn it back into this. That's actually a long way. It would be 6. You got to do 10 to the 6. Now they equal each other. One more thing I need to do though. Are these zeros significant?
No.
They are not. So these don't need to be there. So it's just times 10 to the 6. Because you only keep the significant digits once you put it in scientific notation. There shouldn't be any extraneous zeros anywhere. If it was this, now those are significant, and I would. Does that make sense? Anybody else want more scientific notation? If you still feel lost on it, look at this quiz on scientific notation here. It's the 10 we just went through, but I'll work on this database thing by Monday. But you have that to help you practice, to help you understand, to help you know whether you understand it or not. I'm going to go on to density. I guess I'm going to get is class. It's not letting me download it. Okay, good Lord. Okay. So slide one from the other day, we started with significant figures, did multiplication division rule, scientific notation. I can say some things about, so slide 4 on lecture 1 presentation. This shows you length, mass, time, temperature, amount of substance. These are the, what we call the SI units. They're the standard scientific units we use. What I've got for volume there, volume is a derived unit. It's length times width times height, essentially, depending on what shape you have. Because it's a derived unit, they introduce it separately from this list of units. The significant thing is you can translate between centimeters and milliliters by this. And that's literally the definition of a milliliter. So you've got a little cube that's 1 centimeter by 1 centimeter by 1 centimeter, then you have 1 milliliter. But I just included volume here to be complete. Truthfully, we deal mostly in length, mass, length, mass, and volume. Temperature conversions are just straightforward things. I'll go over that at some point, but all you need is the formula for it. On slide 5, on the top right, there's the formulas to convert between Fahrenheit, Celsius, and Kelvin. And since I'll give you that on the test, I'm not going to spend a lot of time on temperature conversions. You just apply those formulas. I'll do it some, but it's just not a thing to harp on. But I just included volume here for you. The symbols here, you've got meter, kilograms, seconds, Kelvin for temperature, mole we'll get to later in the semester. But just to introduce them, just think in terms of this next section we'll go through for calculations. It's mostly length, mass, and volume. But since I'm going to do density next, just as an introduction to some actual calculations. Density. Do you know the units for density? Generally, but that's a general statement, mass over volume. If we're using SI units, we're going to be using grams, and we usually do it grams per milliliters, or you might see kilograms per liter. But that's the units for density. If you can weigh something and then find its volume, and you divide the mass by the volume, that's a statement of density. And we'll see, I'll use ChatGPT things I made just as a guide, but I don't want to spend time auditing it again. But I did make some density. It should be instructive. We just might not be able to trust the answers. Density. All right. Make sure I have the whole board covered. Yeah. I'll go over here. Well, I'll use this as an Question I've got is 5.4 grams per milliliter. So that's a density. The substance has a density of 5.4 grams per milliliter. If its volume, yeah, this needs some work too. If its volume is 25.0 milliliters, so information we're getting from this question, but it should continue and say how many grams. All right, first thing to say here, I'm going to leave density up here. So if you're skipping through that video, you know what I'm talking about. So the question is, here's the given information. Here's the density of this substance, and here's how many milliliters of it I have. So how many grams do I have? The way you solve this is, first, let me make a general statement. Whenever you see units written this way, we write them like that when you're like typing in a Word file or just writing. But immediately take this and turn it into this. The number, this numerical value, goes with the unit up top. So 5.4 grams, and then do it like this. This is a 1. There's always a 1 with the 1 on the bottom when it's written this way. And then this numerical value goes with what's on the top. And that's always true. So we're doing density now. This is a statement of density. But forgot about this. Don't need that. But whenever you see something written this way, we'll have other units that will write this way this semester. Always turn it into this before you start trying to do any math with it. Also notice, you might use it like that, or you might use it flipped over. Just depends on the problem and what you've been given. So you'll either use that, or you'll use that when it's given in a problem. The 20.0 milliliters. That I'm going to put over 1 just to keep things symmetrical. But when I multiply this 25.0 by something, I need the milliliters to cancel and I need to end in grams. So you're going to have some numerical value in grams. This question didn't, ChatGPT didn't ask you this, but it's saying if I have a substance with this density and have this many milliliters of it, how many grams do I have? The question itself tells you what needs to be on this side of the equal sign. So when you're solving problems, you can set this up. The first thing you can write, let me do this. Before you do anything, you go, okay, this is asking me for grams. Make an equal sign. There's going to be a numerical value, and put your G for grams. G stands for grams. So you know that what you do over here has to cancel out to grams. That way you know that grams needs to be on top. All right, 50. So we're going to do that. So this is the information given in the problem. I tell you to go ahead and translate it out into this, and then start to solve the problem, and you figure out which way you need this flipped. Since I'm ending in grams, and the only place grams shows up in the given information is here, so you know that it's this that we need to use. You follow me? So I'm sort of giving you problem-solving strategies. You'll have some given information, and then you're going to have to work that out somehow to get the units that you want to get. We want grams to show up here, but we don't want milliliters over here. So the other thing we have, and it'll always work out, you'll always have what you need to solve 25.0 milliliters. And I like to put it over 1. Algebraically, it'd be the same thing if I didn't put it over 1, I just wrote it right here in the center. But I like always having numerator, denominator, it makes everything obvious to me, so I always do it this way. The rest is just plug and chug. One strategy I'll show you, once you've got the problem set up, I like to do this just to be neat. I'm going to separate the units and the numerical values. Any of you ever do this in high school? You've never done that? Sometimes when it's a long problem, they'll set up all the units like this. But just realize, I don't use that vertical line, but realize here's how they taught you to do it in high school or whatever. And all I'm doing is this. It's literally the same thing. So if you like that, I've heard it called the train tracks method or the unit cancellation method or the dimensional analysis to sound very sophisticated. But all it is canceling units. You okay? You got this confused look. So I like to do this, especially for longer problems. You could have 3 or 4. This is a factor, and this is a factor. You can have 3 or 4 factors. You could have tons of them, but I don't tend to do too many. This is a very simple one. And over here, I've got milliliters, grams over milliliters. That's algebraically equivalent to this. In algebra, you remember that 2 times 5 equals 10, but 5 times 2 also equals 10. So you can, whatever's on top here, if we were just going to multiply across, we're multiplying this times this times this times this. I just rearranged them. You could picture it like that, all in one big thing. Because I could do this algebraically, that's fine. Because you're just going to multiply across whenever you do algebra. Doing that multiplication in algebra, you go 2 times 3, 4 times 5. I guess I still have to reduce it. I'm going to be proper. But let me leave it like that. But you could also do that, and you're going to get the same answer. You could also draw this line if you like to. Units cancel for the same reason. Numbers would cancel. Like if I had that problem to solve, I could multiply with the 2's, but I could just cancel them. And I'd have 3/4. So that's what I mean by the units cancel. It's the same idea. You're canceling. If it's the same exact thing on the top and the bottom, they cancel. I like doing it like this because this you can visually inspect. You go, yeah, that brings me down to grams. But that's really just a double check. We knew that all the way at the beginning. We were literally asked for that. So the units, once you get the units together, if you do it the way I did, cancel them out and make sure, double check that you're getting the units you want, because that means you probably did it right.
Those numbers at the top are just example numbers, right?
Yeah, that was just a quick little lesson in algebra to remind you. All right, and this you do in your calculator. This you do by inspecting by hand. And of course, this really boils down to just multiplying 25.0. All right. My calculator says that's all my calculator said, 135.
This would be 140, right?
Yes. So now we got to go back to what we've been learning. How many significant figures?
3.
2.
So that needs to be in 2. So it's those 2, and the 5 rounds the 3 up. 140. With no decimal. So that means if I had a substance with this density and had this many milliliters of it, that means if I went over to weigh it, weigh it would. So one more thing to say in solving density problems.
Could you repeat where you got the 140 from?
And 35.
It's 35 right and then 140.
We were essentially doing this. What was it?
5.4.
We were essentially doing this piece of math. Who asked that? We were essentially doing this piece of math. Once I calculated in my calculator gave me that. That's 2 significant figures, that's 3 significant figures, so this needs to be 2. So I'll underline those 2 and go, that's what I'm keeping. This is going to be turned into a 0 though, just because of where it is. But the 5 rounds of 3, so 140 without a decimal. Is that okay? All right. So, kind of a warm up for problem solving is these density problems, but notice this. I'm going to use D for the numerical value, and I'll stay with grams per milliliter. I'll use M for mass. No, that's already confusing. Do this. Some numerical value, grams per milliliter. All right, listen to this. Whenever you have one of these simple density problems, you're going to be given 2 numbers and you're trying to find the third. As long as you have 2 out of 3 of these variables, you can find the third, just with a bit of math. So you're either going to be given density in grams and asked for milliliters, or you'll be given density in milliliters and asked for grams, or you might be given grams and milliliters and asked to calculate density. There's only 3 ways to ask this simple problem. The one I just did was gave us density, and yeah, I'll say volume. It was milliliters, and we had to find volume, mass, and grams. The only other ways you can do this is you'll be given density in mass and grams, and you ask for volume in milliliters, or you might be given volume in milliliters and mass in grams, and you're asked to calculate the density. So just realize that there's 3 different ways you can get this question. So let me do an example of the other 2 ways you might get this question. So the first one we did was like this. You were finding mass. So let's say you have a problem that says, gives you a density of 2.46 grams per milliliter, and it says you have so what if that's the 2 pieces of information that are given? Well, again, so picture a problem that says the substance has a density of this, and you have this many grams of it. What's the volume of that sample that you have? And again, in the question, there will be towards the end, there will be a question mark, and what's in that question is how many milliliters. So you already know you need to end on milliliters. So problem solving strategy, a substance has this density and you have this many grams of it, said some way in the English language. And then the last thing it'll say is how many milliliters. That's how you know equal sign, milliliters, and you're going to have a numerical value that you're probably going to round or find significant figures or whatever. You know you need to end in milliliters. I've told you to take something like this and think about it as 2.46 grams to 1 milliliter. Or you might have 1 milliliter over 2.46 grams, it just depends on what you're being asked. In this case, we're given grams and we need to find milliliters. So that tells us that this is the one we want to use. Milliliters we want to preserve, and grams we want to cancel out. So we're going to use this one, this form. So now I've used this, flipped over, and now maybe it's obvious. As long as I get grams up here, grams will cancel, and milliliters will be what's left. And I'll just put a 1 here, prop it up. That'll do it. And if you need to split it out, like I did before, you can, but this is essentially 96.13 divided by 2.46. I haven't mentioned the phrase exact yet. I probably should have said something about it when I first started talking about significant figures. But if you have one thing, or you have like, say, how many of these do I have? You would go, there's 4 of them, and there's no fractions. There's definitely no fractions here. 4. And you're tempted to go, that's one significant figure, but it's not. This has an infinite number of significant figures. That's why it's exact. These are significant. Knowing when a number is exact is just a skill to have, but it's really kind of obvious, so I don't harp too much on it. So I'll mention that here. But when it's an exact number, we call it an integer, and we don't tend to write all those numbers. But when it's exact, when it's an integer like that, that's an infinite number of significant figures.
How do you know if it's exact?
I'll get to that in a minute, but it's kind of obvious, so I'll just tell you as we go.
Okay.
For your problem right here, for the, is the 2.46 supposed to be grams over milliliters?
Well, that's the definition of density. It is grams over milliliters.
But for your problem,
And so what I tell you to do is first turn that into 2.46 grams 1 milliliter. Allow yourself to realize that's what that is saying and write it that way. But you might use it flipped over. It just depends on the problem. If I flip it over, I take the units with it. So you'll either use it like that, or you'll use it like this flipped over.
it doesn't change anything about it.
No, it doesn't. I mean, you just use whichever way is going to solve the problem for you.
How do you?
And you don't know which way you're going to do it until you look down here and you go, okay, I need to end in milliliters. If you look up here, milliliters only shows up in one place. So you look there and you go, okay, I need to make sure that's on top, which tells you you're using this. What's on top will be preserved. What's on the bottom is going to be canceled. That makes sense?
And you said what's on top is going to get preserved, so on that, the 96.13 and the 1 ml, would it be the grams that gets conserved or the milliliters?
The grams are going to get canceled.
Okay, and it's
There's
because-
grams on top and grams on bottom, so they cancel.
Okay.
And there's no other milliliters anywhere else.
So whatever's on the top and bottom, that gets conserved.
What's on the top gets preserved.
But there's 2 different units at the top. So how do you know which ones to use?
But this. You look here and you go, I need to preserve milliliters through this calculation.
Okay.
The only way to do that is to have it
So
on the top.
milliliters gets conserved, not grams.
Right.
Okay.
I probably should have written out a question, but all these density questions boil down to this. You're given 2 things and you're asked to calculate a third.
Okay.
We knew we needed milliliters, so I wrote that here. And then when I looked at the other stuff I had, I only had milliliters in one place. So I made sure it was on top, and I did that by flipping this. Everybody follow that? Are you cold? The rest of this is just the units cancel, you end in milliliters. And we're just gonna divide this by this, 3 significant figures, 4 significant figures, so this has to be 3. All right, so let me say something about exact. Because you notice, even in the other one I solved, I just kind of ignored these. I didn't say anything about them. That's the thing, these are exact. When you have one of these that has unit over unit, this one, where I tell you a 1 goes with, that one is exact. You don't have to consider it for significant figures. Because you're tempted to go, well, you're multiplying by 1 here, dividing by 1 here. Why isn't it 1 significant figure? Right? That should make you think twice and go, wait a minute, what happened to that 1 significant figure? That's the thing, that's the idea of exact. When it's exact, it's an infinite number of zeros. So this has 4 significant figures, this has 3, this has infinity, and this has infinity. So we're still following the same rule. The one with the least number of significant figures is the one we put our answer in. But just notice, whenever you see, we'll come across these in other places, grams per milliliter. The one on the bottom, I told you has a 1. That one, the one that's associated with a unit on the bottom, that's infinitely accurate. It's exact. So you can ignore that when you're dealing with significant figures, because it's infinite. And this little magic one I stick here, that's infinite too.
If your number was like 450, when the significant figures, like 450, when the significant figures about 2, or would it be like,
450?
like not anything related to this problem, just if you had a number of that?
If you had that number,
Would it be infinite? Or just-
there might be some situations in this world where that happens to be an exact number, depending on where it came from. Our numbers are almost always going to be 1. Our exact numbers are almost always going to be 1.
Yes, not for anything to do with this problem, just if we were to see that number, if we were trying to figure out if it was exact or if the significant figure was there.
The best way to know whether it's exact or not is this. These, the ones that are on the bottom, that I told you you stick a 1 on, that's exact. Those are exact. And this one too. That one that I stick there to make that be on a numerator. So the ones here are exact, and that's almost always what's true. So allow yourself to look at that and go, wait a minute, why aren't we doing this in 1 significant figure? And then go, oh, these ones are exact, so we don't have to consider them for significant figures. The cases where we use something other than a 1 and they're exact, it'll be obvious when we get there. I can tell you what they are. So exact numbers is an important thing, because otherwise you would look at this and go, why isn't our answer in 1 significant figure? It's because of this idea of exact that I hadn't talked about yet.
So is it the same logic, like going through like the difference between like if it wants you to convert like kilograms to grams or
Yeah.
whatever? Like even
The
though
one
it
is
might be
exact.
Even though it might be like 10 or like 1,000.
I'm almost to that in the lecture. When it's metric to metric, like meters to milliliters, they're both exact. But I'm almost there. It's the standard / English measurements where you have like 4 quarts in a gallon. That 4 and that 1 are both exact for the English standard. Okay, so I've done this. Let me finish this one out, just so you have an example worked out. 96.13 divided by 2.46. My calculator says but I'm only keeping 3, right? Keeping those 3. The 7 rounds the 1, so the answer here is 39. I still have to fix the density database, but those will be available either later today or over the weekend. I'll put up an announcement when I have these things fixed. There's one more way you can be asked. It's this. If you're given the grams and the milliliters, you can calculate density. So let's say given. So let's say you get a problem that gives you grams and gives you milliliters. Okay, so what am I going to do first, following the way I've been doing these? What? Yeah, you could do that. Or no, you can put these at the bottom. You do that first. And maybe you don't have to put the number sign there, just so you can write a number in it. But you're given grams, you're given milliliters, you're asked to calculate density. So you know it's density that goes here on the right side of the equal sign. These don't have any slash over something or slash over something. So I won't be splitting this one out like that. But realize, if you look here, you know you want grams on top and milliliters on bottom. And that just makes our units, there's nothing to cancel these. So both of those survive all the way over here, and that's what we want. And the rest is just pull out the calculator.
Yeah, that's the same.
So many of the problems we do are all multiplication division because it's mostly conversions. So we use that rule most of the time. Divided by 23.44. My calculator says my calculator says 0.921507.6. How many significant figures do I want? 3, so it's those. So what's my final answer? The 5 rounds to 1, so it's 0.922. That's the answer. And yes, you could write this. Now that you have it, you could go. You could, but there's kind of no reason to because you're at the end. You're not doing any more math. But I always turn them into this when I'm doing math because it just makes it all so much more obvious. So density, there's your introduction to doing some real calculations with units. What's next? So 3 different ways you can be asked that question on density. What's next in mine? I didn't put a slide with density there. So let's focus here. All right, I told you guys I would give you this stuff for a test, so you don't have to memorize all these. But let's work with let me get an introduction here though, and I'll write these. So what you see there so standard/English conversion to metric or metric to standard. We have these. This is what I told you I would give you. One centimeter. All right. So this, in the top left here on slide 4, under link, I guess I should put some massive volume there, but let me work with this for now. Notice what's in that box. These are conversions between this system of units and this system of units. Meters, that's metric. Yards, that's English, non-science. Engineers use this stuff, but most scientists don't. So meters is the SI unit, and this is the English/standard unit. I'll say English. This book said our standard measurements are these, the SI units, and I wish I hadn't used that word because people call these standard. Inch, yards, the volumes are things like gallons and quarts and pints. And what is that one? What's the other one? And then volume. That was volume. Mass is pounds and ounces. I don't know, is there anything else in here? Pounds and ounces. But all of these are relating between this and this. There's also relating just staying within the English measurements. And there's also metric. All right. When you have these SI units to English, SI units to English, that's inches. English, inches to, this was centimeters. Not even word exact there. So English to metric, metric to English, that's miles. This is English to English right there. And this is English to metric. All of these are relating the metric system to the standard system, except for this one. This was miles and feet. Okay, first thing to say is these are representing, they're written as equalities, but these are all conversion factors. Another thing to say is the ones are exact and the non-ones have the significant figures. So you can ignore this, the ones, and consider them exact. So like I said before, it's kind of obvious. It's these ones. We never make measurements that are one significant digit. It's just pointless. So the ones are the exact ones. But what you want to do is, like if I need a conversion between meters and yards, turn it into that. Similar to what I said before, it's just this time you've got an equality. But this is how you're going to use it in math, in a math problem. So you take the 1, you put it over the yard, or you might use it maybe you'll use it like that. It depends on the problem you're solving. If you're given yards and you need to get meters, you'd use this. If you're given meters and you're trying to find yards, you'd use this. If I said I had, if something is 17.3 meters long, what is that in yards? That's this. Well, meters on bottom, and yards on top, and now I'll just fill it in. So I'm using that one. These are exact, so we can ignore them. This is ultimately just multiplying 17.3 by 1.0936. The meters cancel, we end in yards. And then whatever that is calculated to 3 significant figures. Sorry. I gotta remember to back up. Those are just barely on the board. Conversion factor. Converting meters to yards. I will give you these on a test, so have a list. Don't try to memorize them. It's just wasting your efforts. There is one weird one here. I suppose somewhere along the way, engineers or somebody decided we would make this exact. So I guess we consider that exact, so this is exact too. But if you want to see that as three significant figures and do it that way, that's fine. I think they're crazy for doing that. It probably ends up being a 0, 0 or something. They're like, oh, we'll just estimate it there. But for precision work, I mean, you can't have NASA doing this. So I don't know, I guess it's a standard everybody uses, but you can use my rule that the ones are exact and the non-ones are the ones inexact that you count for significant figures. This is just confusing, but confusing to me. I don't know why anybody would do that, but I've noticed they started saying that in textbooks, so I guess some standard organization that does the standards has decided that. We will do more of this and start solving some problems in these. And I will get the database fixed. Oh, I have a couple minutes. Let me round out this discussion. Whenever you have conversion factors, if you are going standard English, that's the point. For this, the ones are exact, like I just said before. When it's metric to metric, for this one, when you're doing metric to metric, both of them are exact. Meaning, so there's using an equality, 1 liter is 1,000 milliliters. If I wrote it this way, which is the way you'll write it to do math, you've got a 1 and a 1,000. Both of those are exact. When it's metric to metric, both are exact. When it's English to standard, did I say exact? Yeah, I did, that's right. Both of them are exact. When it's standard, only the ones are exact. The non-ones are you have to consider significant figures. When we're doing metric to metric, your significant figures comes to what you're converting. Like it would be, I have 836 milliliters. How many liters is that? So you'd have 836 here. That would give you your 3 significant figures. These you can ignore for significant figures. You have to use them in your calculation, but you don't use them to decide what the answer needs to have for significant figures. English to English. For English to English, they're both exact. They're both exact because they're by definition like 4 quarts equals 1 gallon. How many cups in a quart? Is it 2? I think it's 2. Okay. Now you have some non-ones, but they are exact. It's because that's the definition. Someone decided, let's split the gallon into 4 things and let's call it a quart. Definitional, but it's exact. So there's an infinite number of zeros, an infinite number of zeros after the decimal. So that's the only other thing I'll say. It's only in English to metric that the ones are exact and the non-one is inexact. So English to English and metric to metric, both the top and bottom are exact. And it's the number you're given to convert. It gives you all your significant figures. All right, we'll pick it up there Monday, and I'll get this database sorted out.